Greetings and welcome to Managing Delivery of Your App via DevOps. My name is Brian Benz. I'm a cloud advocate at Microsoft, and I will be your host for this session for the next 45 minutes or so. Before we get started, here's some session resources. Please feel free to take a picture now. This slide will also be re-shown at the end of the presentation for those of you who may be just getting here or getting here late. ACA-MS Mod 50 is where you find all the information for this session, and then ACA-MS My MS Ignite the Tour is where you find information for all the sessions. All right, so let's move on. Today we're going to talk about DevOps. Going to give you a little bit of an intro to DevOps so that we're all on the same page, and we're going to talk about the key items that you want to keep track of when you're implementing DevOps projects, which are people, process, and products. I'm going to give you a demo of DevOps in action. We're going to change something on GitHub. It's going to go through a build and a release automatically, and we're actually going to have a little bit of A/B testing at the end, which will include some audience participation. So please have your phones ready. We're going to have you go to a site, and some of you will see our new version of the website. Some of you will see an old version of the website, assuming everything goes well. All right. So the evolution of people, process, and products. Have a look at this little video I'm going to show you here. I think it's a great illustration of the way things have evolved, not just in racing, but also in IT. So let's check this out.
But Holland comes in for a pit stop. Time to refuel and change tires. Lou Moore himself changes the tires. Only 4 crew members, including the driver, are allowed to work on the car. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch.
So basically just note that there's, only 4 people are allowed to access this car. Think about that as your legacy app. In the olden days, only 4 people could actually access a vehicle or a application in production. No one else was really allowed to touch it, and releases were slow and but reliable. It's only about a minute, but it seems like longer.
The tires are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stopped.
All right, 57 seconds. That's all it took, but let's see how things are done in a modern context. There you go. I think that's a great example of the way things used to be done versus the way things need to be done now. In order for those team members in the newer car to get things done in a competitive way, everything had to be done concurrently, and everyone had a specific task. Much more access to the actual vehicle versus the old one, where only 4 people were allowed to access. Now there was, more than a dozen out there, all doing things at once. And because of that, everything went quickly. Also, because of that, if you think about it, there's much, much more potential for things to go wrong. So what's happened? Along with the actual needs of going faster, the people have got better at actually doing their jobs. The process is obviously better. Everything happens concurrently and fast. And the product is actually better as well. So they have air. Instead of having a hammer and guy knocking off the wheel with a big hammer, they have air wrenches now that pop those things off in seconds, and they're built custom for that. So I think that's just a great example of the challenges you face in IT as well. People, process, and products have to evolve so that you can actually build new software and meet the needs of your organization while also matching the speed of your competitors. So let's talk a little bit about what is DevOps. DevOps is a union of people, process, and products to enable continuous delivery of value to our end users. That's a great quote from a colleague of mine, Donovan Brown. And I really, really want to stress the word value here. If you're not delivering value, then there's really no need to actually put any of this into practice, because it does take some work to set up. But the people, process, and products, let's talk a little bit about that and how you can actually deliver value. This is a report that comes out every year. This is the 2019 Accelerate State of DevOps report. It's by a group called DevOps Research and Assessment, DORA for short, which was recently purchased by Google Cloud DevOps. So it's actually part of the Google Cloud DevOps and SRE group now. But I've selected some interesting tidbits from the report. First of all, high-performance DevOps companies can achieve 208 times more frequent deployments based on comparison with people that might not have a DevOps implementation or have a very basic DevOps implementation. So high-performance DevOps companies can actually achieve 208 times more frequent deployments. And that probably scares the heck out of some of you. But if you notice over on the left and the bottom as well, they also have a 7 times lower change failure rate. So how do they actually implement a system that allows them to have 208 times more frequent chances of something going wrong, but 7 times less, 7 times lower change failure rate at the same time? Well, the answer is a good DevOps process, and that includes the people, process, and products. 106 times faster from commit to deploy. That's something that's really, really important as well. If you have a much faster process for commit to deploy, all those menial repetitive tasks that are required to actually get your code from a commit to test to release, you have more time to focus on the actual features and the things you want to deliver to your organization versus having to make sure that everything happened in a expected way. And if something does go wrong, on the off chance that it does, they have, in this particular case, 2,604 times faster incident recovery, meaning they can roll back, they can fix things easier, and there's very little or no downtime when something does go wrong, because things still go wrong, but you want to make sure you have systems and processes in place to account for that. So people are really the most important part of implementing a good DevOps system. If your dev team is still saying, hey, it works on my machine, ops team, you just make it work, I don't care about the details in production, and your ops team is telling the dev team, hey, you guys aren't giving us enough to actually make this scale and secure, and you're really not helping us out and making sure that we can actually do our best job. If you have those sorts of situations happening from an organizational perspective, and it's usually a top-down issue, your DevOps system, no matter how good your processes are or how much you spend on products, really aren't going to work. So people are really, really, really the most important part of the puzzle. And that's something you just have to decide in each organization how you're going to set up, depending on how the actual teams want to work together. But basically, you do have to make sure that the people are on board with your DevOps project. That's number one job. Number two job is making sure that everything flows nicely between your typical development lifecycle. So the planning for this particular application that you're working on has to be easy to communicate to the develop and test team. And the develop and test team have to be able to communicate easily with the release team. And then one of the things that's often overlooked is monitoring and learning. So, and the idea behind this is you make a plan, you pass that on to dev test, you pass that on to release. Did the thing that was released actually solve the problem that was the original idea in the plan? Did we fix issues? Did we enhance the product? how are people regarding this? And the only way to really get that kind of information is by monitoring the difference that a release makes, and if that release is actually doing the job it intended and changing the behavior on your applications. So that's just a little bit about process. Now let's talk about products. Once you have your people and your process in place, products are key as well. And the offerings that we have at Microsoft, of course, are on Azure, but also on your local machine. So we purchased GitHub a while back. You might have heard about that, and everything seems to be going well so far. They're retaining their autonomy, and they're building some pretty amazing things, actually. We also have Visual Studio, of course, for actual developing these things and testing as well. The full, complete IDE. Some of you may have heard of Visual Studio Code. Visual Studio Code is an open source on GitHub text editor with a ton of extensions that you can use. We deliver all of this through a product that I'm going to show you today, Azure DevOps. We can also use GitHub extensions, and we have something new called GitHub Actions that I want to tell you about too. But if you don't see your products for DevOps on this slide, do not worry about that. We're actually going to be showing you how you can leverage your existing infrastructure, your existing investments in any kind of DevOps that you've done in the past, and make it work with Azure and with Azure DevOps and all the tools you see here. We actually have partnerships with a lot of the traditional tools that that are not part of the Microsoft ecosystem, and I'll show you some examples of that in a little while. And this is where I usually show a show of hands. Of course, I'm recording this, so it's hard to do, but I usually do a show of hands here that asks people, how many people have used Jenkins before? And typically a quarter or half the audience raises their hand, and I say, hey, don't worry about that. Okay, I'm going to show you a specific example of how you can preserve your investments with Jenkins later on. Okay, so GitHub Actions, I do want to show a little bit of something there. We have an announcement that came out a little while ago, and GitHub Actions is something that actually supports CI/CD. It's in preview right now, but it's going to be going into GA inevitably later on. And it's a pretty cool thing. It has multiple language support. You can do some interesting things like CI/CD. You can actually build a whole system that automates your workflow in GitHub itself and allows you to do things like evaluate pull requests, test them before you actually have to do anything manually. This is just a link that we'll have later to show you some of the details on Actions. But today we're actually going to focus on Azure DevOps, actually. I did want to make sure that you were aware that the GitHub Actions are there as well. So, as well as GitHub Actions, the other thing I want to show you actually is operations. We actually have Azure Monitor, and this is the part I mentioned before, is phase 4, which is the monitoring and learn. We have Azure Monitor, which helps you manage your releases once they're implemented to see if they're actually doing the job you intended them to do. We also have Azure Policy, which is great for data and organizational governance. We have Azure Automation for organizing some of the more menial, mundane, repetitive tasks that you need to do. And Azure Security Center helps you manage any security for this. So let's actually drill into DevOps, part of our delivery. Azure DevOps has several components you can see here. Azure Boards is a great way. It's based on Kanban boards, and it's a way to actually plan your implementations and time things correctly, making sure everything happens in sync exactly the way you need it to, and communicate deadlines and make sure that developers are assigned to a task and they understand the task and the deadline, and that the release team understands everything that happened during the dev phase and the planning phase when it actually comes to release the product. We actually have Azure Repos as well. Azure Repos are similar to GitHub repos. You can do everything on Azure Repos you can on GitHub. One of the possible advantages with Azure Repos is that everything is inside of your organization. So you can create teams from your own organization's identity management system, which you might have in place. Typically, in a Microsoft shop, that's going to be Azure Active Directory or Active Directory. And you can control everything and manage the teams from within your domain, inside Azure Directory or inside whatever identity management system you use. Azure Pipelines is actually what we're going to focus on today. And Azure Pipelines has two phases, the build pipeline and the release pipeline. And we're going to spend plenty of time on that, so I won't elaborate on it right now, but you'll see how that all works. And then we have Azure Artifacts. Azure Artifacts is a way of managing the artifacts that are created from a build or from elsewhere. And you can share them efficiently and also use them in builds and releases as part of your pipelines. Last but not least, we have test plans. It's a way to test web apps and actually have load testing, web testing, and other kinds of testing built into your workflow when you're working with Azure DevOps. All right, tacked onto that, as I mentioned before, we have GitHub, we have Actions, but we also have links with GitHub, including extensions. So Azure DevOps is integrated with GitHub via extensions. And I'm going to show you an example of the Azure Pipelines extension a little bit later. But basically, if you go into GitHub, there's a marketplace, and there's tons of extensions in there that you can use with Azure and with other tools as well. Okay. So let's talk a little bit. I mentioned before people, how can dev and ops use people, process, and products to actually work together? What does each team, dev and ops, bring to the table when you're implementing a good DevOps project? Well, the dev team can provide code, of course, and code expertise. They can do unit testing. They can work on a GitHub repo, and they can help with CI/CD automation because they're the ones who actually understand the code and what needs to be built, etc., etc. Ops team, they can contribute an Azure DevOps project. So the dev team needs to work on a project. The ops team says, hey, here's a project you can use as your sandbox. They can provide web servers. So anything you need to actually put this into staging or production. They can provide scaling. That's why they want to provide the web servers or any kind of infrastructure you have for building this, because they want to build in scaling and security. They can also help with CI/CD automation, and they can help manage monitoring as well. So this is the way that the dev and ops team can work together. And in a particular example I'm going to show you today, this is how they do actually work together. So just bookmark these ideas here, and I'll be showing them to you throughout the process. All right, so let's go into a scenario. So here we are at the Tailwind Traders website, and it's a Thursday afternoon, and the sales team has decided that they actually want to run an experiment over a holiday weekend, which starts tomorrow. What they want to do, if you look at the website right now, as it sits, this is the website in production. It's on an Azure web app, which I'll explain what that is in a bit. But basically, right now, free shipping is on $100 or more orders. And that $100 shipping is actually cutting into margins right now. And the sales organization would like to see if they increase that threshold for free shipping to $250. What happens? Does that affect sales? And does it affect sales enough to mess up the margins even more? Okay, so basically the idea here is let's have an experiment where we change the shipping cost to see if that affects the sales. The ops team and the dev team come back to the sales team and say, hey, I've got a way you can do this called A/B testing. So what we'll do is we'll have half of the people over this holiday weekend routed to the $100 free shipping, and we'll have half the people routed to the $250 free shipping. We'll monitor activity, and we'll see which one of them results in the better margins. So in other words, maybe you have a few less sales at $250 shipping, but the margins might be okay. So the sales team approves that, and now they say, okay, great. So it's Thursday. Can you put that into place by tomorrow? Because we want it for the weekend. And because the ops and devs team have a great DevOps system in place, they say, of course, sure, absolutely, we can do that. So let's get going with that demo. So the first thing we want to do is we want to actually change the code. Let's do that by going into our code here. We've got everything nicely set up in a JSON file for a configuration item like that. And right now you can see free shipping is $100 or more. So let's just change that to $250. All right, change that to $250. Great, that's easy. Now I'm actually in Visual Studio Code, and this is an open source text editor, as I mentioned before. And I've installed this thing called the GitHub pull request extension, one of the cool extensions we have. And this was actually written by GitHub. So it notes here, you notice that little blue circle popped up when I changed this code and saved it. It notes that there's a file that's out of sync with the repo on GitHub now. So I can stage this change. I can commit it, change shipping to 250. Okay, let's edit that because Brian can't type. Let's commit that. All right, and now we're actually going to do a sync, which will do a push and pull out to our GitHub repo. So that's it. So we changed the code, we pushed it to our GitHub repo. Pretty straightforward, simple stuff. Now what we want to do is we actually want to implement a process that each time there's any changes that happen in our GitHub repo, it triggers a build, and that build triggers a release automatically, but not all the way to production. It actually triggers it to the A/B testing that we talked about before, where half of the people are going to see the new shipping threshold and half the people are going to see the old shipping threshold. So let's get over there. So to make that change, first we get started with checking out the commits. So we'll make sure that the commit that we put on our Tailwind Traders website, there it is, change shipping to 250. Great, that's done. Now we actually want to connect this repo to an Azure DevOps project, which is going to manage the build and the release for us. So let's go into the marketplace. I mentioned before GitHub extensions, Azure Pipelines. Azure Pipelines is the extension we want to use for this. This is written by GitHub, and it basically connects a GitHub repo with an Azure DevOps project. I'm sorry, not written by GitHub. This one was actually written by Azure DevOps, by Microsoft. I've already installed it because I've done this a couple times. So what I need to do now is configure Azure Pipelines. Azure Pipelines, the build pipeline actually specifically, to connect with my repo. So in this case, I want to just use the bbenz Tailwind Traders website repo that's on GitHub. I want to save that. And when I save it, it actually takes me away from GitHub now, and we're still in the extension, but it takes me into an Azure DevOps project. And in this case, in our fictitious company, Tailwind Traders, the ops team has provided me with an organization I can use and a project I can use. And when I hit continue, it's going to take me to Azure DevOps, and it's going to ask me to confirm on the Azure DevOps side that I want to work with this specific GitHub repo, bbenz Tailwind Traders website. Great. All right. So the first thing it does is it actually automatically analyzes this repo to see what kind of code it's got in it. And as you can see, there's no one clear answer because we do have all of this code in there. It's a pretty complex little project. But the key thing we have is ASP.NET Core. Can't talk today, but anyway. Then we have some Xamarin that actually runs a mobile app. We have some Node.js and a few other things. And there's a ton of other pipelines that we can actually choose from if I hit show more, but these are the ones we can focus on for now. I'm going to choose ASP.NET Core because this actually builds everything that we need, and we actually have some build files inside here that will actually build the Node.js and the Xamarin app and all that stuff for us. So this is the YAML file that actually gets generated based on that template, but we don't want to use that. In this case, once again, an example of the dev and ops team working together. The ops team has provided us with a pipeline YAML file that we want to use. And this one, theoretically could include something beyond the basic template. It could include some data governance or organizational governance or security, things that the ops team knows that we need. So this is a great example, again, of the dev and ops team working together. They gave us a project to work with in Azure DevOps, so we didn't have to set that up. They gave us a YAML file to work with. We didn't have to set that up either. So what I'm going to do is I'm actually just going to save this and run. And what it's going to do is going to take this YAML file called Azure Pipelines YAML file, and it's going to commit it back to the master branch. And the reason why it does that is from now on, any changes I make in the repo locally and push to my GitHub repo will automatically be picked up and generate a build in Azure DevOps. So a full end-to-end system here. So it's nice. Everything's automated. I don't have to think about it. It's going to push, it's going to run a build. And this build is actually going to run some tests and build an application that I can actually deploy. So I'm just going to wait for this to be queued. Looks like it's ready. Great. So agent is ready for the job. It passed all the tests, and it's actually starting the build. Now, it takes about 6 minutes to run. I know that because I've been working with this for a while now. Just like any developer knows their code, they know how long it's going to take. So while that's going, let's actually build a release. Let's build a release that we can actually use with this to make a full end-to-end commit to GitHub, build on Azure DevOps, and release. Because this is a brand new, pristine, empty project that the ops team gave me, I just added a build, and we're going to add a new pipeline. And this pipeline is actually going to handle the release for us. Now, there's a bunch of different stages you can go through here, and there's a bunch of different templates you can use to actually deploy things for different purposes, Java, Azure App Service. Now, if you recall, I mentioned before, our Tailwind Traders website is actually on a Azure website. So in this particular case, I can use the Azure App Service deployment template to create my release pipeline. So let's just start there. We'll call the first stage staging. Okay. All right, but that's nothing. We just named it. Now we actually have to do a task. And this task is going to be deploying to an Azure App Service. So first thing I need to do is introduce it to my subscription. And then there's all kinds of app services that I can choose from. I know this one is web app on Windows, but I could use a Linux containers, or I can actually build some functions, API or mobile apps as well as part of app service. In this case, we're doing a web app on Windows. And because it's my subscription, it's a web app on Windows, I know that the ops team has actually provided me with a staging server and a production server. We don't want production here. We want staging. There we go. And then I can save this. Great. Okay. So that's stage one. Okay, we're going to take an artifact. We're going to add this artifact after the build, by the way, and set it up with continuous integration. The first thing we do, though, we got staging. Now we actually want to move to production. So, copy of staging. Go in here. We'll call this one production. Okay. Then we want to change the task. Here's the task down here. All right. In this case, the task is going to go to production, not staging this time. We're going to save that one as well. All right, cool. All right, so when we look at our pipeline now, we got staging and production. But don't forget, we promised the sales team an A/B test. How do we actually implement that A/B test? Well, that's actually something we want to do through the web app itself. So let me show you how that works. We have a, if you go into production website, here's the overview. This is the URL, the bbens tailwind production azurewebsites.net. Here's the actual Tailwind Traders, same thing. So we know we're in production right now, but we've got this thing called deployment slots. And deployment slots can be used for a couple of different things. There they are, deployment slots. In this case, we're using them for A/B testing. So bbens tailwind production, 50% goes to production, and then we have a new deployment slot here. And inside this deployment slot is a totally different website inside of the URL. So basically, if I look at this canary, for example, I've already preloaded it, so it takes a minute to load. But the actual URL for the other deployment slot, the Canary deployment slot, is https://bbens/tailwind-production canary.azurewebsites.net. But the users don't see that. All they see is the production site, and 50% of the traffic gets routed to the Canary site. Right now, both of these sites are identical, but we want to actually make one of them, this one, Canary, route the new website that has a $250 shipping, and we're going to keep the old production site working with the $100. So that's how we actually implement the A/B testing. So let's get in here. How do we actually implement that and tell Azure DevOps what to do with it? In this case, we just clone the step again. In this case, we're going to call this one Canary. All right. And this one we're going to name to production. All right. That's easy. Down here in the tasks, so this is similar to what you saw from the other two steps, except now we click on Deploy Azure App Service. Okay. And in here, I click on Deploy to Slot. All right. I choose my resource group. Now, resource group is just a way of grouping things. In fact, I should show you that. Here's a little bit about resource groups. So this is an Azure portal dashboard. And basically, I've got a backend, which runs Cosmos DB and a bunch of other things in this application. And we've got a front end, which actually runs the production and the staging sites and that Canary app, Canary deployment slot as well. Each one of these things is contained in a resource group, and that's how you actually organize things in general. Okay. So in this case, the bbens Tailwind front-end resource group, and we look in there and we see two slots, production and Canary, just like I actually showed you in that web app a little while ago. All right, so let's save that. So now we actually have staging, Canary, production. Beautiful. We got everything going. Everything's in a nice straight line. Everything's going to go. However, right now, how do we actually stop the build that we just made from just flying straight through all these processes and getting out into production? Well, there's a couple things we can do. Here, we can say, we can add a post-deployment approval. We can choose that. Now, what happens here is anytime, the dev team can actually control this, and they can go through, they can go into staging, they can pass this to the testing team, and the testing team can approve the staging to the next phase. And to do that, you set it up with a post-deployment condition. All right, so that's going to flow through our Canary. So we're going to have the new $250 shipping cost in staging and Canary at this point. We don't want it to go into production, so let's prevent that. But we're going to do that with a pre-deployment approval. Okay, and there's a difference I'll explain in a minute. So there's times, why do we have post-deployment approvals and pre-deployment approvals? That's because there will be times when I can say as a dev, yeah, we can move that to the next phase, but then the ops team says, not so fast, we don't want to implement this until Friday evening. We want to make sure that we implement this only on Friday evening, so you can set up a pre-deployment condition for that. We also have all kinds of triggers, aside from just putting, the simplest one is putting a pre-deployment approval with somebody's name in it. You can also set up things like Azure policy compliance. You can invoke a custom Azure function. You can call an API. If you're using open source products, you can call an API, for example, that goes out and checks for vulnerable products inside of your code base before they get released to production. And you can do all kinds of custom API and work items and a few other things too. But for now, we're actually just going to use that simple pre-deployment approval and have it ready to go. All right, so let's check in on our build. And it looks like our build is done and the build was successful. When it's actually built, you can see the logs in here. You can see all kinds of details on how everything was built from stage to stage. Looks like I got a couple of warnings, but those aren't a problem. There's no failures. So this job is basically ready to be deployed. So let's go back into releases and let's edit this release again. Okay, and let's set up that artifact. So the build produced an artifact, and that artifact is sitting there waiting. All right, inside the BBenz Tailwind project, there is a build artifact called BBenz Tailwind Trader's website. And we're going to choose the latest version of this. There's other options as well. You can specify which version you want at the release time, but that doesn't help for an automated process. And then you can actually control it with tags. You can choose a specific version, and you can actually do a branch as well. So you can actually control a branch, have that go into production, and have a master go into production. In this case, we're just going to do latest master branch. Okay, so that saves that. So cool. So another thing we want to do is set up the continuous deployment trigger. That will ensure that anytime there's a successful build, it will automatically post this. So now we got everything done. There's going to be a change in the code. It's going to push to GitHub. GitHub is going to trigger a build in Azure DevOps. Azure DevOps is going to, if there's a successful build, is going to trigger a release down here. That release is going to flow to staging. It's going to wait for me to approve to go to Canary. And once that's done, there's going to be a pre-deployment condition that goes in here before it actually is allowed to go into production. All right, so let's save this. And let's create a release. Now, this is the only time you have to do this manually. After this, it would be all done automatically, because we set up that continuous integration process. So basically that's queued, it's in progress. It's going to take a couple of minutes to do that. So while that's cooking, I'm going to show you a couple other things, because we only have a 45-minute session here. I mentioned before you can keep your investments, and I asked you guys how many people are using Jenkins, but here's a good example. You know, these are the 4 phases that I talked about before: plan and track, development, test, release, and monitor and learn. And some of you are probably working with a lot of these products already. As I mentioned before, you're able to keep your investment in these products because we work closely with pretty much all of them. And we've been doing a lot of interesting things with them in terms of integration, in terms of making sure that if it runs on Azure, it runs the best on Azure. If it's not running on Azure, that's okay. It still integrates with all the tools that we have for builds, deploys, and everything else you can do with these tools on your organization. So if you know, when I talk to organizations, they have a huge investment already in their dev tools and their deployment tools. You can keep those investments, and you can still do some pretty cool automated stuff with Azure DevOps. So today I'm actually going to show you Jenkins in particular. Jenkins itself, we actually have a partnership with Jenkins. Several years ago, the creator of Jenkins, Kazuki Kawaguchi, came to me and asked if we could provide some resources on Azure for them to help build Jenkins on Azure. And the result of that is, let me show you. If you go to ci.jenkins.io, you can actually see Jenkins being built using Jenkins and running on Azure. Over here on the left, every time Jenkins gets a pull request, they actually test it against Ubuntu, different versions, Windows, different versions. They test it in containers. They test it in Kubernetes. They make sure that everything runs and everything is going to work as expected before they actually evaluate the pull request and to be merged. So this is live, ci.jenkins.io. You can check it out anytime you like. It's not a private site, it's public. And you can see here that Jenkins is actually running several processes. And like I say, this is because this is live. I never know exactly what I'm going to be seeing here. You can see some successful tests. You can see some unsuccessful tests. This one's running Ubuntu, a specific version of Ubuntu. And down here we've got Windows 2012 running some other things. And I just lost it, but I saw a couple of Docker things running here as well. And Docker is running in something we call Azure Container Instance, which is that ACI there. Basically, this is all automated, and it's a great partnership that we've had with Jenkins. Jenkins themselves have helped us build a couple of architectures. So Jenkins on VMs, you can find an architectural reference for that if you want to actually run Jenkins just like the Jenkins project does on Azure. We also have Jenkins on containers. Jenkins on containers is similar to the way they actually implement their container-based testing and running of Jenkins as well. And the main thing as part of this is we've invested a lot in Jenkins plugins. So Jenkins project needed a whole bunch of plugins for actually implementing things. And you can use the same plugins that they use for their infrastructure. They're battle tested, they're implemented, they're running every day. Here's a sample of some of them, but if you just search on the plugins.jenkins.io, you'll find a ton of plugins that you can use. And the way it works in Jenkins really is, you know, a lot of people have invested a lot of money in Jenkins to do build and test. But when it comes to releases, they do custom options, which is FTP and stuff like that. What you can do with Jenkins, there actually is a plugin that you can use to integrate a build on Jenkins and a test on Jenkins with a deployment in Azure DevOps. And that way you get secure, reliable, auditable deployments that you didn't have before in general. And you still are able to keep your investments in build and test, which you've made in Jenkins over time. Okay, so let's go back to our release. I'll approve this. And this approval is going to go to the next stage. So let's actually check this out. If I look at the logs here for the staging server, we can verify that our change has gone through. Down here. All right, so there you go. It used to be $100. If you look in production, it's $100. If we look in staging, it's $250. Okay, so let's see what the status is on the actual release. Okay, pipeline. Okay, it's still in progress, so just take a second more. There we go. Okay, beautiful. So now we've got our code with a $250 shipping and staging in Canary, and it's waiting for approval to be moved to production. And this is where we need some help. Hit this site. Because we've set this up, as you saw with the deployment slots at 50/50, half of you should see the $100 shipping cost, and half of you should see the $250 shipping cost. I can't show you here because as soon as I set up and link to one of those sites, chances are it's going to go back to the same site again, even if I use private browsing, because it uses sticky sessions to do that. So the only way to actually really test this in the real world, and this is a great real world test anyway, is for you guys to hit this site. Okay. And then, by the way, so this is recorded. So normally at this point, what I do is I get a show of hands from the audience telling me how many people hit the $250 shipping site, how many people hit the $100 shipping site, and then we move on from there. Okay, in review, we covered what is DevOps, so helping you get up to speed so everyone's on the same page. And then we dove into the most important aspects of DevOps, which is people, process, and products. And then we went over a demo, which is DevOps in action, showing you how we actually changed that shipping cost. And then after that, talked a little bit about Jenkins and how you can keep your investments. All right, and some information that you'll find useful here. Docs Alert, ACA MS DevOps Resource Center, and the DevOps Docs are actually really good resources for you to get started with Azure DevOps and integrating it with whatever tools you might be using now. All right. Also, we have MS Learn. For those of you who aren't familiar with MS Learn, it's a preset made version of, it's basically a tutorial site with multiple different modules that you follow through. And eventually they do tie into certifications as well. Here's the slide I promised at the beginning with the resources. So session resources, code on GitHub. All event resources are there. Feel free to take a picture. Just another, this is recorded once again before the tour starts. So each location will have to update this slide with their timing, because the timing will change depending on the location, number of rooms, things like that. So everyone will have to check this slide out and update it as they go along. And thanks for coming. Hopefully that was useful, and please do remember your evaluations. Please make sure that people remember their evaluation. So once again, my name is Brian Benz. I'm a cloud advocate at Microsoft, and thanks for coming.